So let's upgrade the difficulty slightly. In this case, we're not going to test for validity, but something in principle simpler, entailment. Entailment is basically mini-validity, right? You have one formula on the left, and if it is true, it means that the formula on the right is true as well. My fingers look awful and blotchy right now. I even considered like wearing gloves for this, but that would just look creepy, incredibly creepy. From like wearing black leather gloves doing this, you would wonder about other habits or something. Okay, the less said about that, the better. Anyway, how do we do this? So, it's mini-validity. So we just start by assuming what we are given, Formula 1 over here, and get to Formula 2 in the rules of propositional logic. So, Formula 1, capital A, or not B, not the value, very crucial, B or C. You might be wondering, why are they capital now as opposed to P's and Q's from above? Well, if you read your priest, he tells you these are variables for whole formulae. The capital letters are variables for whole formulae. The lowercase letters in propositional logic are variables for claims or propositions that we can feed in to the logic. Here, A could stand for a formula in the logic itself. B and C, and these would be how these individual formulae are related to each other by the connectives in the logic and how the operators work on them. So, it's a level of further abstraction. And yes, once you get advanced in logic, there are many levels of abstraction. So, this actually doesn't add any complexity whatsoever to what you're doing. I just changed it up to show, in fact, that it doesn't really add any complexity. What do we do? Well, we got this or statement. Or statements mean at least one of these is true. What are the two? On the one hand, A. On the other hand, this thing. It is not the case that B or C. There's nothing you can actually well, there are things, I should say, but nothing useful that you can directly get out of this. And if you want to just follow that convention from above, okay, that's all we're given, so we're just going to draw the line there. This is where you'll see truth trees earning their title. We have to branch here, because all we are told is that at least one of these things is true. To reason any further, we have to make further assumptions, as it were. So we have to divide the space of possibilities. If we know at least one of these is true, well, let's go on the one hand with the possibility that the first disjunct, the first thing in the disjunction, is true. And on the other, that the second thing in the disjunction is true. So this would be line 1, and despite me skipping over these other lines of the notebook paper here, this would be line 2 down here. This is purely practical tip. You want to make your splits wide enough to where you can A, write under them so the two sides don't mix, and B, once you get more sophisticated with this, the splits will contain splits. The branches will have twigs coming off of the branches. So you have to space things out well enough so that you can graphically represent it all. Okay. A or not B is what we're trying to go for. We want to prove that whichever of these two things is true, A or not B is also true. So that means using these two branches, we have to prove A or not B on both of them.